LeetCode 543, diameter of a binary tree. It is an easy question, and let's see what it says. We are given with the root of a binary tree, and we have to return the length of diameter of the tree. The diameter of the tree is the length of longest path between any two nodes in the tree. This path may or may not pass from the root, and the length of a path between two nodes is represented by the number of edges between them. Suppose this is our binary tree, and these are the edges. These are the leaf nodes, and this is the root. So we have to return the length that is longest among all the lengths between the leaf nodes. Okay. So for example, if we count the length between 4 and 3, it is 1, 2, and 3. Okay, we counted it 3. If we count the length between 4 and 5, we will sum up with 1 and 2. So among all the lengths we have counted, we saw that 3 is larger. Okay. Suppose if we come at this binary tree, this is the root of binary tree. Okay. And these are all the leaf nodes. So we have to return the length between these leaf nodes, and the length that we are going to return must be the longest. So let's see which length is calculated to be the longest. For counting the length, we will count the number of edges between the nodes. For example, if we see these two nodes, then we count that there is 1 and 2 edges. Okay, fine. The length is 2. Okay, if we count the length between 1 and 3, we see that it is 1, 2, and 3. So the length between 1 and 3 is 3. And the length between 2 and 3 is also 3. Okay, so if we count the length between 1 and 4, it is 1, 2, 3, 4, 5. It is 5. And if we count the length between 1 and 5, it is 5, 6. It is 1, 2, 3, 4, 5, and 6. Fine. So we have to return the longest path between any two nodes. Okay, this was from the 1. Now let's suppose if we count from the 2, then we will also sum up with 5 at 4 and 6 at 5. Fine. And if we count from 3, so we will end with the 1, 2, 3, 4, 4 here, 5, and 5 here. Fine. So we have to return the longest length, that is 6. So how we are going to write the code of it? It is very simple. Suppose we have this root node. So we have to write a function that will calculate the height of left subtree, and that will also calculate the height of right subtree. Okay, fine. So for that we are going to make a function. We are going to write a function that will be calculating the height of right and left subtree. So we know that we can write it like left is equal to node dot left, and right is equal to node dot. So by these two recursive functions, we will be getting the left subtree and the right subtree recursively. So how we are going to find the diameter? Diameter is actually the length of left subtree and the right subtree. Fine. How we know that? We know that by the thing that if we count the diameter of this part, so what we will do? We will do this counting of this subtree and the counting of this subtree. Okay, we count that it is 1 and it is 1 and it is also 1. So it sum up at 2. If we have to count the length between these two nodes, then we have to count the number of edges on the left side and on the right side. That is, on the left side that are 1 and 2, and on the right side it is only 1. So it became 3. Fine. And if we have to count the length of this part, then we will count the number of edges on this side and the number of edges on this side. That will be 1, 2, 3, 3 on the right side, 4, 5, 6, 3 on the right side. So what we did the left plus right. Okay, we did the left plus right. Thus diameter is equal to the left plus right of the tree. So we are going to write it like this: diameter is equal to left plus right. Fine. Okay, so that is clear. Now the question is how we are going to add the length, how we are going to add the number of edges in the either left or right. For that, we are going to make a variable, for example, length, that will be equal to 1 plus either right or left. This slash is not for divide, this is for either left or right. Okay. So by this the we are going to add an edge in the left or the right. Okay, fine. So now that we have got almost all of the important things that we need in our function, and we have got all the concepts from this diagram. So let's move towards our code. So first of all, we are going to make the diameter that is currently 0, and then we are going to create a function that will calculate the diameter of the height of both sides, the left subtree and the right subtree. Suppose we name it by depth. Okay, once the function will be ended, we will just add the root node in it, and then we will return the diameter. Fine. So now let's create the function. So in the function, first of all, we are going to call the diameter, that will be non-local diameter. It is because if we do not call it in the function, it will always start from 0 at every iteration. Okay, so we have to avoid it. We have to just create the diameter in the function so it remain non-local, so the scope of variable remain global. Fine. Okay, now we are going to make the base function, that is if we do not have any node, then we have to return 0. Why we did that? Suppose we start from here and recursively we go to here, and it also says that first of all go to the left side, so we go here, and it says that okay, check my left child. Okay, so when we come here, we see that there are no more nodes on the left side or on the right side. So if we come at this case, so we will do that we are going to return 0, because there is no further level at which we come. The base case says that if there is no further node, then return 0. Okay, so now we are going to call the recursive function for the left child and for the right child. So left is equal to depth node dot left for the left child and node dot right for the right child. Fine. Now that we have got the recursive function for the left and right child, now we are going to make the important thing, that is the diameter calculator. So the diameter is equal to left plus right. Okay, we earlier saw that the diameter is actually the length of left and the right subtree. If we have this as a diameter, then we will return these two lengths. If we have this as a diameter, we return this and this length. So this is actually the left part and this is actually the right part. So we return the left subtree and the right subtree. Okay, so we return the left subtree and the right subtree. Now, since we have already a diameter, so we have to check either the current diameter is maximum or the coming diameter is maximum. So whichever it will be the maximum, we will return it. Fine. Now we are going to return the length of side that we are going to continue with. Okay, so when we calculated this as a diameter, suppose we calculated this as a diameter currently, so what we did that we said that the diameter is of length 3. Fine, but we cannot return this as a result of function, because if we return this as a function, then it will not be able to iterate towards the parent point side. Okay, because this cannot do anything, this part cannot do anything with this part, it cannot help seriously. So we have to return the length of the longest side. Either this side is long, so return this side, or if this side is long, then return this side. So in the current case, this side is longer, so we will return this side, and we will add this side with the root node, and then we will check on the other side if we get the longest side or not. So for that, we are going to check either um, left side is longest or the right side is longest. Okay, so whichever will be the longest, we will return it. And since we have to add the parent as well, we have to return the parent node as well, so we will return um, one as a addition with it. Okay, so now our function has been completed. So now let's run this function. So our function is complete, so we will submit it. Okay, now let's submit it. Our solution beats 45%. So now let's make a little bit change. So what we are going to do is we are going to say if left is greater than right. So what you do, you add return plus fine, else return. Now let's run this. So fantastic. We have got 93% in beat case. So this is a good solution. So now let's find out its time and space complexity. So the time complexity of this function is linear. Okay, O(n), and the space. So how it is linear? We are creating a recursive function that will only run one time per node. Okay,